Okay, so the next thing that we have essentially in our textbook, and remember that when I say the textbook, I mean the 2018, 2019, 2018, 2019 textbook that I have essentially uploaded to Udemy along with this course, which is essentially not the latest version of these textbooks. I'm not working with those versions yet. So so then what you need to do in order to essentially to follow these courses, essentially you will just simply download this PDF document from Udemy along with this course, and then you can use it, and then we can move forward and we'll have no problems. Okay. Now the next section is introducing 10,000, which gives you essentially some interesting insights into numbers, into the decimal number system, and we are going to discuss that. Now, in the decimal number system, essentially you have the one-digit numbers, you have the two-digit numbers, three-digit numbers, four-digit numbers, and so on and so forth. So then if you talk about essentially the one-digit numbers, we have essentially the numbers 0, for example. If we start from 0, for example, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right? So the one-digit numbers are 0, 1, 2, 3, all the way up to 9. Then essentially the two-digit number, when you add and here you can see that. Now let's start this list with the 1 to essentially, I don't want to bring in any sort of ambiguity. So if now this number over here 1 is the smallest one digit number. And 9 is basically essentially the greatest one-digit number. Right? Now what happens essentially in the so 9 essentially is the greatest one-digit number. Now we can essentially expand the number system that we have. Now in order to expand this number, of course you need to move forward in these numbers. And in order to move forward, you will take essentially the greatest, for example, one-digit number, which is 9, and if I add 1 to it, I will get a 10, which then automatically becomes essentially a two-digit number, right? So 9 plus 1 automatically becomes a 10, which is a two-digit number. And so then we can essentially talk about basically the two-digit numbers. So about the two-digit numbers, you can go essentially 10, 11, 12, and so on and so forth, all the way up to 19, and then you have 20, and then essentially you have 21, 22, 23, and so on and so forth, all the way up to 29, and then 30, and then we have basically 31, 32, and note that essentially all of these numbers are basically two-digit numbers. 33 and so on and so forth, all the way up to 40, and then we have essentially 41, and then over here we have essentially 41, 42, and so on and so forth, all the way up to basically 49 and then 50, and then we can go all the way up to essentially 51, 52, and so on, all the way up to 59 and then 60, and then we can essentially go to 61 and 62 and so on and so forth, all the way up to essentially 69 basically, and then a 70, and then we can go all the way up to 71, and then for example 72, 73, and all the way up to 79 and 80, and then you can go for 81 and 82 and all the way up to basically 89 and 90, and then you can essentially go for 91, 92, all the way up to 99, and then you have essentially the 100, right? So then that means that essentially when you get to 100, you will get to essentially to 3-digit numbers. All the way up to 99, we are dealing with essentially 2-digit numbers, right? So which means that essentially 99 is actually nothing but the greatest 2-digit number, right? It is the greatest 2-digit number. And then basically we can then talk about essentially the 3-digit numbers. So to get essentially the 3-digit numbers, you'll get the greatest 2-digit number, which is 99, and if you add 1 to it, you'll get 100, which is essentially nothing but the smallest 3-digit number. Right? And well, then you'll get to essentially 101 all the way up to 110, 120, 130, 140. So we can essentially keep going with this number, meaning that you can go all the way up to 110, and then you can go all the way up to 120, you can go all the way up to 130, you can go all the way up to 140, you can go all the way up to 150, you can go all the way up to 160, and well, you can just keep going with this all the way up to 170, all the way up to 180, all the way up to 190, all the way up to 200, and then you have essentially 210. Essentially you can then go essentially all the way up to 300. These are still essentially 3-digit numbers, all the way essentially up to 400, and then all the way up to 500, all the way up to essentially 600, all the way up to 700, all the way up to 800, all the way up to 900, and all the way essentially all the way up to 999, which is the greatest basically 3-digit number. Which is the greatest 3-digit number. And then we can essentially move to essentially the 4-digit numbers, right? So if I take essentially the greatest 3-digit number, which is essentially 999, and add 1 to it, I'll get 1000, which is essentially the smallest 4-digit number, right? And then basically you can essentially, in these numbers, you can essentially go to you can move to 1000, 2000, 3000, 4000, and so on and so forth, and you can move essentially up to 9999, which is essentially the greatest, which is the greatest 4-digit number. Okay? The greatest 4-digit number. Now, after the greatest 4-digit number, if you take the greatest 4-digit number, which is a 9999, and if you add 1 to it, you will get essentially a 10,000, which is essentially the smallest 5-digit number. And of course, you can just keep going with this. Essentially, for example, you could then essentially you can move, with this you can move essentially to 99,999, which is essentially the greatest essentially 5-digit number. And then basically, if you take the greatest 5-digit number, which is 99,999, and if you essentially add a 1 to that, you will get essentially basically a 100,000, right? Which is the smallest essentially 6-digit number. And then of course, then you can just keep moving with this number and make it essentially 999,999, which is then essentially the greatest, 6-digit number. And of course, you can just simply keep moving with these. Then essentially you can essentially 999,999, if you add a 1 to it, you will get essentially essentially you will get a 1 million, right? Which is then essentially the smallest, I don't know, the smallest 7-digit number, and then 8 digits and 9 digits and so on and so forth, right? So that's basically how essentially the decimal number works. And that's I mean, it would be interesting and also useful to know these things about the decimal number system, so that sometimes essentially you can do a couple of things with them. Now, a couple of interesting things that you can do essentially with this knowledge is that basically, so essentially beyond 99 there is no 2-digit number, because it's essentially the greatest 2-digit number, and 99 is the greatest 2-digit number, and the greatest 3-digit number is 999, the greatest 4-digit number is 9,999, and then essentially if you add 1 to that, you will get essentially a 10,000, right? Which is essentially what they wanted to introduce over here. Now the pattern over here is that if you have essentially the greatest 1-digit number, which is 9, if you add 1 to it, you'll get a 10. If you take essentially the greatest 2-digit number, which is 99, add 1 to it, that's 100, which is the smallest 3-digit number. If you take essentially 999, which is the greatest 3-digit number, and then add 1 to it, you'll get the 1000, which is the smallest 4-digit number. So this is the greatest, basically the greatest 1-digit number, the smallest 2-digit number, greatest 2-digit number, smallest 3-digit number, and then greatest 3-digit number, smallest 3-digit number. And then also it's interesting to note that basically that the 10, which is essentially nothing but essentially the smallest 2-digit number, basically it's nothing but 10 times a 1. 100, which is the smallest 2-digit number, is essentially 10 times a 10. 1,000, which is the smallest 4-digit number, is nothing but 10 times 100, 10 times 1,000, 10 times 10,000, and so on and so forth, right? So this way, essentially what you can do is that you can essentially convert this addition into a multiplication, which is of course going to be very useful in sometimes essentially in algebra. You have to do some sort of, you want to prove something, or you want to write something down in a different way, and these are going to be always these are essentially always going to come in handy, meaning that a 9 plus 1 is nothing but 10 times 1, and 99 plus 1 is nothing but 10 times 10, and 999 plus 1 is nothing but 10 times 100, and so on and so forth, right? Of course, there is no need to try to remember any of these things. As we go through the exercises, automatically you're going to learn these, so you don't have to worry about any of these. And then the greatest 4-digit number, which is essentially 9,999. If you 9,999, if you add a 1 to it, you'll get a 10,000, which is the smallest, basically 5-digit number. So the new number that comes next to 9,999 is 10,000. It's called 10,000, and further, of course, 10,000 is nothing but essentially 10 times 1,000, which comes after this thing over here. So 10 times 1, 10 times 10, 10 times 100, and then 10 times 1,000. So that's essentially what sort of essentially this sort of pattern that you can see in these numbers. And it's also important to note essentially these all of this different material over here, meaning that you need to be familiar with what is the smallest 1-digit number, the greatest 1-digit number, and then basically smallest 2-digit number, the greatest 2-digit number, and then what is basically the smallest 3-digit number, greatest 3-digit number, and so on and so forth. Okay. Now in the next video we will talk about I think the place value. There is also some interesting information over here, although we have talked about the place value. We have talked about it previously, but there is going to be some interesting information over here which we can work with in different contexts. Thank you. Okay, so hello and welcome back. Now in this video we will talk about the section in the text which essentially talks about revisiting the place value. And of course I know that I'm aware of the fact that I have essentially talked about the place value many times already. Once, a couple of times in the previous course, a couple of times in this course. But sometimes essentially I have to keep repeating something. Essentially I have to come at it from a different angle and keep repeating it so that I can essentially make a couple of new connections in your mind, meaning that essentially connection from essentially all of these different connections that need to be made, some connection from this concept to that concept, from this concept to that concept, and so on and so forth. Essentially, these have to be mined, so that these have to be made, so that essentially your mathematics is, well, I mean, so that your mathematics has everything that it needs to have in it. Okay, so that's essentially the reason why sometimes I have to repeat myself. Now suppose that essentially I have essentially 2,536 marbles in a bag, for example. Okay, so these are essentially my marbles, and I have 2,536 of them, and well, I want to count them, and I want to know how many marbles I have in this bag. The number I don't know from the very beginning. So I keep counting them, and in order to make my life essentially easier in counting, what I will do is that basically I will essentially I take, for example, a couple of marbles out of the bag, and then I basically count, and then I see that, for example, I have 10 marbles over here, so I put them together so that I know that essentially the groups that I'm making essentially consist of 10 marbles. So these groups essentially consist of 10 marbles, and I put these together so that so that essentially I don't make mistakes in counting. Meaning 10 marbles that I put together, then later on I know that this is 10 marbles. I don't even have to count it anymore. And I essentially I can just simply keep counting another basically 10 marbles, another 10 marbles, and so on and so forth, right? So this way I can make sure that I'm not making any mistakes, right? Now let's suppose that essentially I have essentially I've made many of these groups basically. So I put essentially 1, 2, 3, 4, 5, 6, 7, 8. That's a 3, 6, 8, 9, and 10. I put essentially 10 of these groups of 10 together like this. This is a group of 10. So this is essentially 10 groups of 10. This is 10 groups of 10. Right? Now 10 times 10 is essentially nothing but 100. So I have essentially now a group of 100. And suppose that basically now I make essentially a couple of these groups of 100. So that's another group of 100. That's another group of 100, and so on and so forth. Now suppose that essentially now, since this number is fairly large, 2,536, meaning the number of marbles basically, I will come up essentially with, well, many of these groups of 100. So then basically these groups of 100, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, I put them together in a group. I put them together in a group. So that's a group of 100. So this is essentially 10 groups of 100. 10 groups of 100. So which means that essentially 10 groups of 100 would be basically 10 times 100, which is equal to 1,000, right? And you can see essentially where I'm going with this. So I have these marbles over here, which are essentially these loose marbles. So this is essentially a group of 1, or essentially a 1. This is essentially 10 marbles put together. So this is a group of 10, right? Now I have put essentially these groups of 10, I put them together 10 of these groups of 10 would be essentially a group of 100. So now I have essentially these groups of 100 as well. And then these groups of 100, I put 10 of them together to make essentially groups of basically 1,000. And then of course you can do essentially keep doing the same thing and make essentially groups of 10,000. You can make groups of 100,000 and so on and so forth, right? And suppose that now basically 2,536, that's the number. Now suppose that I have essentially two groups of thousands basically. Suppose that I have essentially two groups of, meaning that when I'm done with this essentially grouping and counting, now I count and I see that I have two groups of thousands, which I'm going to write in number, two groups of thousands and five groups of hundreds, and three groups of basically 10 and six groups of 1, for example, right? So now I do the essentially grouping everything that I'm doing, and then basically I count all the groups that I have put together, and I see that essentially I have two groups of thousands basically. I have five groups of hundreds, I have three groups of 10, and I have six groups of 1, right? So now I have basically, and my number essentially is made based on the decimal number system, right? In the decimal number system, basically here is the ones place value, here is the tens place value, here is the hundreds place value, and here is the thousands place value. So which means that essentially the groups of thousands, I have two of them, so I put a 2 over here to mean that essentially I have two of these groups of thousands. And I know that essentially this 2 essentially refers to the groups of thousands because of the fact that, well, it's in the thousands place value in the number, right? Then I have essentially 5 of these groups of 100, so I put a 5 over here again to mean that I have essentially 5 of these groups of 100. I have 3 of these groups of 10, so I put a 3 over here to mean that I have essentially, well, 3 of these groups of 10. And 6 groups of 1, I put a 6 over here. Now essentially, this way essentially I have made my number. So now my number is 2,536, and now essentially you can express the number of the objects that we had, express their number in the form of a number in the decimal system, right? So then it should be fairly straightforward to essentially to expand this number, meaning that now that we know essentially how everything works together, we can expand this number. For example, we can say that essentially 2,536 is essentially, well, of course, two groups of thousands. So that means essentially 2 times 1,000, right? And then essentially we have also 5 groups of hundreds. So that's 5 times 100. And then we have 3 groups of 10. So 3 times 10. And then we have essentially 6 groups of ones. So that's essentially 6 times 1. And that's basically how you expand your numbers basically. Now this expansion of numbers has many kinds of applications, of course. Now let's say that, let's take a look at the text over here. Let's see if there's something to discuss. So for example, that essentially here we have started with a 2-digit number. The 2-digit number is essentially a 78, and so it is essentially a 70 plus an 8, right? So then if I want to write a 78, which is essentially a 2-digit number, that's the same thing as basically, well, the 7 is in the tens place value, so that means that I have to write essentially 7 times a 10, right? And then basically this 8 is in the ones place value. That means that essentially I have 8 groups of 1. And so if I put these together, 7 times 10 is equal to 70, plus essentially, and 8 times 1 is equal to 8. So 78 is nothing but 70 plus an 8, right? Now you can, of course, you might have essentially essentially a 3-digit number like 278, for example. So if I have a 278, this 2 is in the hundreds place value. That means that I have 2 groups of 100, right? Plus another, this 7 is in the tens place value, so that's 7 times 10, right? And then I have basically this 8 over here, so this 8 is in the ones place value, so I have 8 times 1, that's 8 ones basically. So this is the same thing as 2 times 100 is 200, 7 times 10 is 70, and 8 times 1 is equal to 8. That's a 278. Right? Now we could also have, for example, a 4-digit number. For example, 5,278. So 5,278, we have this 5, which is in the thousands place value. So that means that essentially I have 5 groups of thousands. This 2 is in the hundreds place value, so I have 2 groups of hundreds. This 7 is in the tens place value, so I have 7 times 10. And this 8 is in the ones place value, so that's essentially 8 times 1. Now if you calculate this, 5 times 1000 is a 5000, 2 times 100 is a 200, 7 times 10 is 70, and basically 8 times 1 is equal to 8. That's how you can write the 5,278 is the sum of these numbers. Of course, this has its own applications in meaning that essentially once you at least you need to spend a little bit of time expanding these numbers, so that you essentially you see the different parts of a number basically, and that essentially works in different ways in your mind. So if I have, for example, a 5-digit number like a 45,278, and I want to expand this number. So that's essentially that's a 1, 10, 100, and basically 1,000, and that's a 10,000 place value. So essentially that's 4 groups of a 10,000, right? Then 5 is in the thousands place value, so that's 5 times 1,000. Then 2 is in the hundreds place value, so that's 2 times 100. And 7 essentially is in the tens place value, so that's 7 times a 10. And then you have 8, which is essentially in the ones place value. So if I multiply these together, that would be essentially 40,000, and that's a 5,000. That's a 5,000, that's a 200, and that's a 70, and that's an 8. So then essentially 45,278 is the sum of these parts basically. And of course when you when we read the number, we read it in the exact same way. We say 45,278. We essentially read our numbers essentially this way. Now let's take a look at these. Let's see what these are. We have essentially the number 20,000. That's essentially 2. All of these essentially are 0. But then we have a 2 over here, which is in the that's a 1, 10, 100, 1,000, and 10,000. So that's essentially 2 groups of 10,000, or essentially 2 times 10,000. A 26,000, for example, would be 2 groups of 10,000 and 6 groups of 1,000, basically. A 38,400, that would be 3 groups of 10,000, 8 groups of 1,000, and 4 groups of 100. Now this number over here, for example, 65,740, is essentially 6 groups of 10,000, 5 groups of 1,000, 7 groups of 100, and then 4 groups of 10. Okay. We have essentially this number over here, and that is essentially nothing but 89,324, which is 8 groups of 10,000, 9 groups of 1,000, 3 groups of 100, 2 groups of 10, and 4 groups of 1. And then the rest you can essentially write them down. I mean, you can solve them if you want to, of course. So that's basically all about essentially expanding your numbers, and I will see you in the next video. Thank you. Okay, so hello and welcome back. Now another number that is I'm introducing this number to you because of a specific reason, and the reason is that the number basically 100,000 in India, it's called essentially the number, most of the time people call it a lakh. They don't say, for example, 100,000 people. They say, most of the time they say 1 lakh people. Okay. So, and of course, now that essentially we have to essentially go through all of these books which originally come from India, more or less. Of course, you have to be familiar with the terminology, and so as a result, I'm just simply introducing the number. And then, of course, sometimes in the news or on the internet, and of course, the word like is used in most Asian countries, meaning in Sri Lanka, or essentially in the countries essentially that you find around India. In those countries, the word like is most of the time used. So it would be you might essentially notice it in the news or essentially in newspapers, things like that. Okay. So now what is essentially 100,000? 100,000 basically is nothing but it's the smallest 6-digit number, right? And we saw that in order to make essentially the smallest 6, for example, any essentially whatever the number of digits that your number has, when that number is the smallest number having those many digits, to create that number, we saw a few videos back that you would take essentially the largest essentially not 6-digit but 5-digit number, the largest 5-digit number, which is essentially what is the largest 5-digit number? So you have essentially 99,999. That's a 5-digit number, and essentially all of the digits have been filled with nines. So that's the largest the largest 5-digit number. Now, if I take essentially the largest basically 5-digit number, which is 99,999, and then basically, and if I add a 1 to this, what I will have is that 1 plus 9 is equal to 10, so 1 carryover, 1 plus 9, 10, 1 carryover, 1 plus 9, 10, 1 carryover, 10, 1 carryover, and then 1 plus 9 is equal to 10, right? So that's 100,000. So which means that then basically, which means that if I take essentially the largest five-digit number, the largest 5-digit number, which is 99,999, and if I add 1 to it, I will get 100,000, which essentially in India, now I will talk about this in detail in a few videos. In India, essentially 100,000, you don't write it this way. You would write it as 1, a separator, the 2 zeros, a separator, and then basically the 3 zeros. And then it is then called basically 1 lakh. It is basically called 1 lakh. Okay? You don't write it this way, but you write it this way. Of course, in all of these, essentially, in all of these courses that we have, we are going to follow essentially the international way of writing the number, but essentially just that's something interesting and useful to know. At least, essentially, sometimes essentially these words essentially are mentioned in these books, in the NCERT books, so you need to, of course, be familiar with that so as to understand the text. Okay. Now, if I have essentially a number like, for example, if I have a number like, for example, 246,853, for example, if I have this number, now if I want to expand this, of course, this is essentially the 10, essentially 100,000, 10,000, and 100,000. So this is the 100,000 place value. So essentially the expansion of this number would be 2 groups of 100,000 plus 4 groups of basically 10,000 plus basically 6 groups of 1,000 plus 8 groups of a 100 plus 5 groups of 10 plus 3 groups of 1, basically, right? And if you do the multiplication, 2 times 100,000 is basically 200,000 plus 4 times 10,000 is 40,000. 6 times 1,000 is essentially 6,000. 8 times 100 is essentially 800. 5 times 10 is 50, and 3 times 1 is essentially a 3, right? So then when you want to read this number, you would read it more or less like this: 246,000, and 1,000 comes from here. 246,000, that means 200,000 plus 40,000 plus 6,000, and then 853. That's basically your number. Now the same number basically then in the essentially in the Indian system, you would write it as 2,46,000 853. That's basically your number in the Indian system. So in the English, basically there is a standard there is a standard based on which essentially we read our numbers essentially in the English language, right? We will get to that in a few videos. I don't remember the name, but based on that standard that we use in the English language, or essentially in mathematics, the number is read as 246,853, right? But then if you were, to read the number based on the Indian system, first of all, you would have to add a separator after the 2, and then you would read the number as 2,46,853. Okay. Now you can basically now this number over here, for example, is a 300,000, which is the same as 3 lakh in the Indian system. This number is 350,000, which is the same as 3,50,000. This number is 353,500, and which is essentially the same as 3,53,500 in the Indian system. And okay, so now as an exercise, you can basically, what you can do is that you can go through these few numbers, expand them, and then essentially write their name in English. And of course, the English system is more than enough. You don't have to write everything essentially in the Indian system unless you want to. So I will see you in the next video, and thank you. Okay, so now we have essentially 2 more numbers that are used essentially in the Indian system of numbers, and that is essentially, one of them is 10 lakh, one of them is 10 lakh, one of them is 1 crore. Now, of course, you know that basically that essentially 1 lakh, was the same thing as essentially 100,000, which you would write in the English, in the English system you would write it this way. So 100,000 would be 1 lakh. So then 10 lakh would be 10 lakh, which is in and of itself seems to be a number actually. So you can write it as 10 lakh. That is essentially the same thing as 10 times 100,000, which is essentially nothing but basically 1 million. Right? So that's 10 lakh. And of course you know that essentially that 1 million or 10 lakh basically is the smallest 7-digit number, right? Now the number 1 crore is basically that's essentially 10 times a 10 lakh, or essentially a 10 million, meaning that the number is essentially, so 1 crore is basically in the Indian system you would write it as a 1 comma, the separator, of course this is only in the Indian system, 1 comma 0 0 0 0 and then 0 0 0. Okay, so that's essentially 1 crore, and of course you see that it's the same thing as 10 million, right? In the English system we write it this way as 10 million. So it's basically the smallest 6, 7, 8 digit number, right? And that's basically all there is to it. Not very important really, but we might actually run into it. Essentially we might actually come across this sometimes in this text. So for the same reason I just wanted to introduce these. Okay, so now let's try to solve these two problems as well. They seem to be interesting problems. So not the first one. The first one you can just simply ignore. The second one, starting from the greatest six-digit number, the greatest six-digit number would be 999,999. Write the previous five numbers in descending order. Okay, so the greatest six-digit number is 999,999. So the previous five numbers would be essentially the same number, meaning essentially 999,999, for example. When you want to essentially to get to the previous number, you have to essentially to subtract 1 from this number, right? So if you subtract the 1, then you will have 999,998, for example. And then by the same logic, basically, you will have, so you have 999,998, right? And then basically you will have, and then you will have 999,997. And then you have 999,996. And then you will have basically 999,995. So that's 1, 2, 3, and 4. And then you will have 999,994 basically. And then you want to write these numbers basically in descending order. In descending order, that means essentially you start from the largest number and you end up with the essentially the smallest number, which is essentially what we have done here, right? Now for the next exercise, we have basically starting from the smallest 8-digit number, write the next 5 numbers in ascending order and read them. So the smallest, when you want to write the smallest 8-digit number or the smallest 9-digit number, 7-digit number, whatever that might be, so we always have essentially the greatest n-digit number. We have the greatest n-digit number, or essentially we have the smallest n-digit number basically, right? And whenever we have the greatest n-digit number, n could be any number, meaning 5-digit, 6-digit, 7-digit, whatever that might be. Of course, since you want to make essentially, you want to create essentially the greatest number, then of course you will have to essentially fill all of the place values with 9s, because you want to essentially make the greatest number possible. So then you would have, for example, something like 999,000, for example 999. That's the greatest, for example, 6-digit number. When you want to write basically the smallest n-digit number, of course, then since the number has to be smallest, you need to essentially use essentially all the smallest digits that you have at your disposal, which is essentially the 0, the 1, 2, 3, and so on and so forth. So you have to pick essentially a 0 or a 1, for example, right? And of course, you know that you cannot essentially start your number with a 0, because essentially, for example, suppose that I write 0, for example, 100,100. That's essentially not a 5-digit number, but basically that's just simply 1,000, which means that's a 4-digit number, right? So then of course you have to start from a 1. You start from a 1 and then you write, for example, a couple of zeros in front of it to essentially accommodate for the number of digits that you want. So then for example 1,000 would be the smallest, for example, 4-digit number. A 10,000, for example, would be the smallest, for example, 5-digit number. 100,000 would be, for example, the smallest 6-digit number, and so on and so forth, right? So here basically what we want to do, we want essentially to write the smallest 8-digit number. The smallest 8-digit number would be a 1, and then basically 7 zeros. So 1, 2, 3, 4, 5, 6, and 7. So then in total we have 2, 4, 6, and 8 digits. And then the number would be essentially 10 million, right? Now we want to write the next 5 numbers. The next 5 numbers essentially when you write a number and when you want to get to the next number, of course you have to add 1 to that number, right? So which means that essentially for example, a 10 million plus a 1 plus a 1 would be a 10 million 1. Or for example, 100,000 plus a 1 would be essentially 100,000 1, and so on and so forth, right? So now I want the next 5 numbers after this number. So then that's essentially 10 million 1, 10 million 2, 10 million 3, 10 million 4, and 10 million 5. And I want to write these numbers in ascending order, meaning the numbers you start essentially from the smallest number, end up with the largest number. So then the numbers in the ascending order would be 10 million 1, and then 10 million 2. So that's 10 million 2, and then you have essentially 10 million 3, and then you have 10 million 4, and then you have 10 million 5 basically, right? So that's basically all of these numbers in basically in an ascending order. Okay, so then I will see you in the next video with the next topic. Thank you. Okay, so hello and welcome back. Now in this video essentially we were actually supposed to essentially work on this section, which is an aid in reading and writing numbers, which is essentially nothing but essentially the fact that these numbers essentially when a number gets a little bit long, meaning that there is many digits essentially in number, then it's not easy to keep track of essentially what is what in the number, so it's not easy to read it. So in such cases essentially one thing that you can do is that you can essentially create these tables, meaning that you can create a table like this, for example, and you have the ones place value, the tens place value, the hundreds place value, right? And put your digits under these headings basically, and then you can keep track of everything that there is in the number. That's one thing that you can do, which is I mean practically nobody actually does this sort of thing, so it's okay if you just simply want to ignore it. If not, you can use it as you like. It's your own decision. Also, you can essentially the same table you can essentially use it this way, meaning that the ones that the tens, the hundreds, and so on, these place values, you can write them in a table, and then write down your number essentially under the basically appropriate headings, and then well, you can of course write the number name. You can write it in words over here, and you can do essentially an expansion of the number over here. All of these essentially you can even expand your table to contain essentially other things. It's all your own decision, but essentially normally and practically nobody does this kind of thing. So if you need to, you can use essentially all of these things, right? Now one thing that helps you to read the number is essentially the use of comma basically, meaning that essentially you have seen that, for example, when I sometimes when I write a number, I write, for example, I want to write, for example, 10,252,000, for example, 657, right? Now I put a comma over here, and I put a comma over here. So this is a comma, and this is a comma, right? So I have, starting from the ones place value, I count 3 digits and put a comma over here. Again, I count basically 3 digits and I put a comma over here. Again, I count 3 digits, and so on and so forth, right? So then this way, basically, you know what you're doing, meaning that, for example, 652, comma, 7, for example, 65, comma, for example, 2, 3, 5, for example, right? So then instantly, as you see the number, you see essentially there is one comma over here, one comma over here, which means that essentially there is 6 digits over here. So whatever there is on the other side of this comma is going to be essentially the million, right? And then if I had another comma and another 3 digits over here, you know that essentially that this is the million, and then this is the billion, right? Because a billion is essentially this number over here is essentially a 1 billion, meaning essentially 1 and 9 zeros in front of it, right? So that's a billion. So that is essentially 1 billion, right? And 1 million would be essentially a 1 and 6 zeros in front of it. That would be essentially 1 million, right? So then based on this, when you see essentially 3, 6 digits and 9 digits, then whatever comes over here, you will read it as so many billions. And when you see essentially 3 digits and 6 digits, then whatever comes over here, you would read it essentially as so many millions, right? So which means that essentially when I have a number like this, that would be 352, and then I have 9 digits over here. And the 9 digits then I don't have to count because of, the number of digits I don't have to count because of the fact that there is essentially these commas over here. And so 2 commas means essentially 3 sets of 3 digits, which would be essentially 9 digits. 9 digits is essentially the billion. So 352 billion 652 million 765,235, right? So when you use the comma, then normally essentially you shouldn't have much problems with reading the numbers. Even if they are very large numbers, you shouldn't have much problems reading the numbers, except that you've started working with numbers very recently, meaning that, for example, you're probably in class 5, 6 or something like that. Hopefully there is people of class 5, 6 as well over here watching these videos, okay? Now in the beginning, of course, again, if you are in class 5 or 6, then you're going to be a little bit slow probably in the beginning. And then if that is the case, then you can always essentially use these types of aids. For example, use a table like this, or for example, use a table like this, something like that basically. But then over time, then as you essentially work more and more with numbers, then essentially using essentially simple commas should be more than enough to understand everything about a number and to be able to essentially to read it, okay? Now the comma system, now the comma that you use essentially in numbers, the way that you use commas is different in the Indian system of numeration than the international system of numeration. So what we use essentially normally in the English language basically and in mathematics to write numbers down, that's essentially the international system of numeration. In the international system of numeration, basically what you do is that if you have essentially these digits over here, for example 9, for example 7, 6, 5, 6, 2, right? In the international system of numeration, which is essentially the usual system that we use, we put a comma over here, and then of course we read that as essentially 976,562, right? In the Indian system of numeration, the same digits basically you would read them essentially this way, or essentially and also the way that you use the comma is different. So the first comma essentially comes 3 digits from the beginning of the number, meaning from the ones place value as you move essentially towards from here as you move towards basically the left in the number. After essentially the first 3 digits are going to be separated by comma, okay? And then the second 2 digits, and then the after this first comma, then you count essentially 2 digits and basically place another comma. And then this would be, for example, the lakh that we talked about, meaning essentially the 100,000, right? So then, for example, if then this number essentially then in the Indian system of numeration would be written this way with 2 commas, but in the international system of numeration with one comma. This number is read in the international system as 976,562. In the Indian system of numeration, this number is read as 976,562. Okay. Now I discussed the Indian system of numeration just for your information. Otherwise, you don't have to really do anything with it unless essentially you're Indian and live in India, or essentially you're Indian, or you're just simply interested in the system or anything like that. Otherwise, for example, if you live in, I don't know, in the US, and so then of course you follow the international system of numeration, and so you don't have to really worry about the Indian system of numeration. Okay. So then what we have over here, the international system of numeration. In the international system of numeration, as it is being used, we have ones, tens, hundreds, and so on and so forth. And so here we have some information about how you use the comma, which I just explained. And then to express numbers larger than a million or billion is used in the international system of numeration. Then one larger than a billion is used. Okay, so we already know all of this. This is not very exciting right now. And this is about the Indian system of numeration, which is essentially the way that the commas are used in a number. So you have 592. So the first 3 digits, and then one comma, 2 digits, another comma, 2 digits, another comma, and so on and so forth. That means that essentially the first 3 digits would after the first 3 digits you have 1 comma, and then after this first comma you will keep essentially adding commas every 2 digits. So 2 digits, 1 comma, 2 digits, 1 comma, again 2 digits, 1 comma, and then you just keep adding those commas basically, right? So now let's take a look at these exercises a little bit. Let's see if there is anything important in them. So you want to read these numbers, write them using the placement boxes, and then write them in the expanded form. So this is essentially something that you could do if you at least do a couple of them. You don't have to use the placement box if you don't want to. You can just simply use commas, and then you can expand them. You can write their names in English and so on and so forth. So you don't have to take the video's time for this. And then you want to know essentially which one is smaller, which one is greater. Do all of that for practice. And then wherever essentially you're stuck with these questions, you can always ask me questions. I will always be happy to answer your questions. Okay. And then you want to arrange these numbers in ascending and descending order. Do that as well. Then read these numbers and then write these numbers using placement boxes and then using commas in Indian as well as the international. You can ignore the Indian system unless you're Indian, and then basically you can essentially do all of this for practice basically, and then you want to arrange them in ascending and descending order. And if essentially in case you follow the Indian system of numeration, you can do this exercise as well, meaning to write the numeral for a number. You can follow the boxes again. 42,70,008. That's a number in the Indian system of numeration. In case you follow the Indian system, you can do this as well. And again, wherever you come across problems and you cannot essentially you have doubts or you cannot solve the problem, you can always ask questions on the message board on the course, and then I will answer all of your questions very happily. And then you can also essentially try these questions, which is you have the following digits. Using them, make 5 numbers each with 6 digits. Put commas for easy reading and arrange them in ascending and descending order, taking the digits, and then make 3 numbers each 8 digits. Put commas and put the digits 3, 0, 4, make 5 numbers each with 6 digits, and then use commas. So for example, over here it says from the digits 3, 0, and 4, make 5 numbers each with 6 digits. That means that essentially you can the digits you can repeat as many times as you want. Probably it doesn't matter really, okay, because we have essentially 3 digits over here, and then we have the number is supposed to have 6 digits. Okay, so that's basically all there is here. And again, I have to essentially to ask you and remind you not to basically not to skip any exercises. Okay, if you skip these exercises, your mathematics is going to be paralyzed, and then you will be responsible for it. I'm giving you each and essentially every piece of information that you need. Now, this essentially going through these courses is a little bit of course it's going to take some work, but the work, when you do it, and when you're consistent, when you're persistent with your work, after some time, meaning after a year or so, then you will get this work to some place where it becomes something like a beautiful thing, like a celebration. Okay, it becomes something, it's like essentially flower growing in you, something like that. Okay, and then you can essentially reap the rewards when you get there. But that essentially all of those rewards come only provided that you go through each and every one of these exercises. Please do not skip, and wherever you essentially come across problems, I'll always essentially answer your questions without fail, without any problems. Okay, so hopefully this video was helpful, and I will see you in the next video with the exercises. Thank you. Okay, so now welcome back. Now we get basically to the first set of exercises in this chapter, and that's exercise 1.1. So there is essentially there are a few things that you need to know about these exercises. First of all, there is usually a few sets of such exercises in every chapter, meaning that, for example, over here you see we have exercise 1.1, and then after a few pages we have exercise 1.2, and after a few pages we should have another set of exercises, 1.3, as you can see. So exercise 1.1, 1.2, and 1.3, and that's it basically. Okay, for this chapter, 3 sets of exercises. Now when you get essentially to these exercises, for example in this case, let me show you essentially what these exercises are and what you can do with them. So exercise 1.1, you see I have these questions over here, question 1, 2, 3, and 4, and that's essentially it. Of course, this is for the, usually you have 10, 12 exercises in each exercise set basically. And these exercises are super important, absolutely important. Now, some of them I will discuss, essentially I will have to discuss because they might be, some of them might be a little bit tricky, or there might be some concept that needs still to be added to the body of the course, and those types of things I use these exercises in order to do so. Okay, some of them I will leave to you, and essentially for all of these exercises I will always leave the solutions for you. Now the ones that I solve myself on the video, the solution is going to be on the video, but then all the solutions are going to be basically in the form of these PDF solutions that I essentially download from tiwariacademy.com. Okay, now essentially whenever there is an exercise, I will go to tiwariacademy.com, download the solution, and put it essentially essentially included in the course basically. Okay, but now suppose that there is some chapter that, suppose that the solution for whatever reason is not there. So there is some chapter basically that we haven't discussed, something like that, you want to do that on your own. For all of these exercises, for the solutions basically, you can go to basically the tiwariacademy.com. So you can open up a browser and tiwariacademy.com. That's essentially TIWA. Make this a little bit bigger so that you can see it. You cannot, unfortunately. So that's tiwariacademy.com. You can find that on Google, and also TIWARI and then academy, all one word.com. Okay, so then when you come over here, you have essentially, for example, this chapter that we are working on right now is essentially chapter 1. This essentially is chapter 1 of class 6 mathematics, right? chapter 1 of class 6, and the title of the chapter is Knowing Our Numbers, and this is the chapter number. And of course this chapter we have taken it from class 6 basically. So then you come to this website and then you choose your class as class 6, right? And then the subject is mathematics, and then the chapter is chapter 1, which is Knowing Our Numbers. So I click all of these and then find the solutions. Now when you come to the solutions, you see there is a whole bunch of things over here, related links and buy NCERT books online and mathematics for senior classes. You don't need to worry about these, or essentially chapter 1 practice tests. You don't need to worry about any of these. Usually essentially on the top of the page, for example, you see over here 6th math chapter 1 solutions for CBSE board. You always want to essentially go for the CBSE board or the NCERT board. There is two things. So for example, over here it's written essentially for the state board. You don't want to essentially have anything to do with the state board, because they are usually, in most cases they are different, at least a little bit different. So you don't want to confuse yourself. You always go for the, so you go essentially for either the, as stated here, either the CBSE board or essentially the NCERT board. Okay. Now, you see over here we have class 6 math Ganita Prakash chapter 1, which is essentially the new, essentially the updated set of textbooks which we are not using right now. Or for example, class 6 math chapter 1 try these. This is the try these questions that basically that come essentially in the text. We had these basically over here, for example, in the chapter as we were going through the chapter. You saw that sometimes, for example, there is something like this. Let's say try these. This try these, essentially that's the meaning of that. And then you have basically class 6 math exercise 1.1 in English and class 6 math exercise 1.2 in English. That's essentially what you're looking for. And as we saw here, basically we saw that the exercise that we were looking for was basically this exercise set over here. And you see that, for example, the first exercise set is exercise 1.1. So then you're looking for exercise 1.1 and exercise 1.2, okay, in English. There is also in Hindi, so you don't want to read in Hindi. And then in the end, for example, on this list there is class 6 math Ganita Prakash chapter 1 solutions. Again, this Ganita Prakash is basically is the solutions for the chapter 1 of the updated new textbooks, and that's not the textbook that we are working on. We are working on the older textbooks basically. Okay. Now you see over here that basically on the exercises over here, or essentially on the chapter itself, I showed you that there is exercise 1.1, 1.2 and 1.3, right? Now, and you see over here there is only 1.1 and 1.2. 1.3 is missing for whatever reason. And this kind of thing happens almost all the time on this website. You need to essentially learn how to use it basically. So then if you come a little bit down here, you see it says 6 math chapter 1 solutions for state boards. And then over here we have exercise 1.1, 1.2 and also 1.3. And then the rest of these, of course, then you don't have to worry about. And then the rest of the page, you don't have to do anything, you don't have to worry about. So then you come over here and basically click on the exercise 1.1 in English, for example. and then the website brings you essentially somewhere to the middle of the page, and you see over here this document type thing. It says essentially mathematics, www.tiwariacademy.com, chapter 1, knowing your numbers, exercise 1.1, class 6, and then the question, and then over here basically we have the answer. So then you have to essentially find some way, either you can read the solutions on this web page, or sometimes, for example, if you wish to, because it's a rather long page, basically probably 50 pages or so there is in this document. If you want to make it shorter, you can always basically go over here and print the page, and then just essentially pick the pages that you want to. If you go to save to PDF, and then instead of all, you would choose custom, and then here you will specify essentially the page numbers that you're looking for in order to save it essentially on your computer, and then essentially read it using a PDF reader or something like that. For example, over here you see that as I come down, the solution is on this page, and this is page 8. You see, you can read hopefully over here that this is page 8 basically, and this is page 7, this is page 8. So I need page 8, and also page 9, and also page 10, right? So I go over here and write essentially page 8 up to 10, 8 essentially dash 10, and then I can basically save this to somewhere on my computer, for example on the desktop as NCERT solutions for class mathematics, and then this I say testing, right, and then test it, and then put that on the website. And this is the document that we got basically. So this is the document that we got, and then basically you have essentially mathematics.tiwariacademy.com, which is this page over here, and you see that chapter 1, knowing your numbers, exercise 1.1, class 6. These are the questions: question 1, question 2, question 3, question 4, the question and the answer, of course, in all cases. And that's basically how you get your solutions for all of these books, meaning that you can go for class 6, class 7, class 8, class 9, class 10, class 11, and class 12. But at any rate, whenever I essentially use a chapter in order to create a course, I always essentially do this type of thing myself and put the solutions somewhere along with the course, so that you have access essentially to all of these exercises. Now that you understand essentially how to get the exercises, so we will then in the next video work on exercise 1.1. Thank you. Okay, so now before we start with the exercise 1.1, there is a couple of things that we need to learn, which are usually not discussed in any textbook on mathematics properly, or sometimes they're not even discussed at all, and you need to learn them so that essentially we can do something with something real and practical with our mathematics. And one of those things essentially is long division. So then essentially we need to learn long division, meaning essentially how to divide, and then we will essentially automate that using long division. And then we will also have to learn essentially a couple of things about dividing and multiplying by different factors of 10, which is very important when you want to do different operations basically on numbers. We will have to learn a couple of things about simplifying fractions, which is again very useful and helpful when you're doing different things on numbers. And finally, we need to learn a couple of things. We need to learn how to solve essentially a certain type of equation, and then we will use all of these in all of these exercises. And of course, there might be other things as we go along. We will take care of them. Okay. Now, so we will start with division, and then we will get to essentially long division. So now, what is division? So in division, essentially what we do is that we take essentially a certain number of objects, and then we divide those objects among a number of groups, basically. For example, among 5 groups or 3 groups, or I don't know, any number of groups, basically. Meaning that we have basically, for example, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, and 9 objects over here, and we want to divide basically these objects. We have basically 9 objects over here, and we want to divide them among, for example, 3 groups. And then in the end, essentially what happens is that then we will have 3 objects here, 3 objects here, 3 objects here, and now essentially we have divided, and then you can say that essentially 9 divided by 3 is equal to 3, which means that essentially we had 9 objects over here, and then we have divided those objects among essentially 3 groups, and each group essentially got, for example, 3 objects, and that's essentially what division is. Right? So now let's take essentially an example of an actual division, essentially how we do that, and then we will make it more advanced, basically. Okay. So when it comes to division, basically what do? I take basically, suppose that I have again the same, basically let's make it 12 objects, for example, 2, 4, 6, 8, 10, and 12. So 2, 4, 6, 8, 10, and 12 objects we have over here. And I want to basically divide these objects among, for example, 3 groups, right? So how do I do that? So of course I don't know how many objects each group is going to get in the end. So I'm going to give 1 object to this group, 1 object to this group, and 1 object to this group. That's the first round of my division. Then I'm going to give 1 object to this group, 1 object to this group, and 1 object to this group. That's the second round of the division. Then I'm going to get 1 object here, 1 object here, and 1 object here. That's the third round of the division. And then I'm going to give 1 object here, 1 object here, and 1 object here. That's the fourth round of the division. So you see now that basically I got 4 objects here, 4 objects here, and 4 objects here, which means that essentially I have 12 divided by, well, 3 groups basically, and each group essentially got 4 objects, right? Now, of course, it's going to be very time consuming if you were to do essentially all of your divisions this way using this model, because, for example, now you have essentially 12 objects here, 3 groups, so this is easy. So this wouldn't take much time. But then the problem is that, for example, you have, for example, 12,324, and you want to divide it by, for example, a 4, and then you want to know what that is. So then you would have to essentially essentially keep doing this distribution over here, which would take probably forever, and of course you don't want to do that. We essentially want to find an easier way to do this, right? So the way that we can make this operation over here, we can automate it. We can essentially, now let me make the model a little bit more complex, and then we will take it from there. So now suppose that I have basically I don't know, many objects basically. So for example, suppose that I have, I don't know, all of these groups of, for example, I have, for example, a 3,253, for example, and I want to divide it by basically and I want to divide it essentially by a 3, for example. Now, whether that's possible or not, we will see, but that's not important for now. So then basically the number of objects that I want to divide is 3,253, which is essentially fairly a large number of objects, right? But then what is actually 3,253? What does it actually mean? So this number has essentially the ones place value, the tens place value, the hundreds place value, and the thousands place value, right? So this over here is the ones place value, this place value is the tens place value, this place value over here is the hundreds place value, and this place value over here is the thousands place value, which essentially simply means that I have 3 groups of 1, I have 5 groups of 10, I have 2 groups of 100, and I have 3 groups of 1,000, right? And so essentially 3 groups of 1,000 would be 3,000, 2 groups of 100 would be 200, 5 groups of 10 would be 50, and 3 groups of 1 would be a 3, right? That's the meaning of essentially this sequence of essentially digits that we write over here as a number basically, right? Now this sequence, if I want to use essentially the block model to depict essentially this number, I could say that I have basically, let's say that for example this is one group of 1,000, another group of 1,000, and another group of 1,000. So that's 3 groups of thousands. So that's a group of 1,000, that's a group of 1,000, and that's a group of 1,000. And then let's say that this is a group of, and then let's say that this is a group of 100, and this is another group of 100. So this is a group of 100, and this is another group of 100. So we have 2 groups of 100. And let's say that this is essentially one group of 10, and that is another group of 10. This thing over here was not intended. This is another group of 10, and this is another group of 10, and this is another group of 10. So these are basically groups of 10, right? So I have 5 groups of 10 here, and basically 3 ones. The 3 ones essentially would be 3 loose pebbles basically that you cannot group them, that you cannot group essentially otherwise, right? Now I want to basically divide essentially, and these are essentially all pebbles, meaning a pebble like this basically. So this is one pebble, this is another pebble, this is another pebble, this is 10 of these pebbles put together. This is essentially this over here is 10 of these blocks, which means essentially 10 of 10 blocks, which is 100 block, which is essentially 100 of these pebbles. And then by the same logic, when you put 10 of these blocks together, you'll get one of these, which is a block of 1,000 basically, which means that there is essentially thousands of these pebbles in this block, which is 100 of these pebbles in this block, which is 10 of these pebbles in this block, in each of these blocks basically, right? Now I want to divide. So what's the best way to divide? Now in order essentially to do the division, basically of course you have to pick the best strategy that you can use. I mean the best strategy, meaning that something that takes the least amount of time and is the most efficient way to do the division basically. So what we can do is that essentially one way that you can do the division is essentially, since we want to essentially divide by 3 groups basically, that means that every single pebble that we have over here, we want to distribute it among essentially 3 groups equally, which means that I have 1 group over here, 3 groups over here. And so then if I started from the single pebbles that I have, then I would put one of them over here, one of them over here, one of them over here, right? And then now I've run out of single pebbles, so I will basically just break one of these up, and then I will have essentially 2, 4, 6, 8, and 10 pebbles over here. Instead of a group of 10, I have 10 single pebbles over here, 2, 4, 6, 8, and 10. And then I would put, for example, one over here, one over here, one over here, and then again one over here, one over here, one over here, and then I would keep going with this. Once I run out of pebbles over here, I will break up one more of these and then one more of these. That's one way to do it. Okay. Another way that I can do this is essentially by going for the largest, essentially for the largest groups that I have, right? Which is easier because essentially you don't unnecessarily have to break things up. You can still keep your groups and still do your division, and of course, given the fact that you don't unnecessarily have to keep breaking things up, it's going to take much less time to do the division, because you saw essentially over here that when I wanted to do the division, so I have these 3 loose ones over here, and I have these 3 groups over here, so I distribute them among these groups, and then I have to break this one single block up. When I break it up, I have 2, 4, 6, 8, and 10, and then I have to essentially keep dividing one by one pebble by one pebble, the next pebble, and the next pebble. So it's going to take forever to do this calculation. So I have to do this over here, then do this over here, and then do this over here. And note that I'm essentially doing the division pebble by pebble, right? And then I have to do essentially the next round like this, and then the next round like this, and then one is remaining. Then I will break the next one up, and so it's going to take forever to do this, right? A better way to do this, meaning that if I don't want to keep distributing each pebble one by one, I could simply use a different strategy that wouldn't require me to break up each and every one of these blocks unnecessarily, right? Meaning that if there was a way that, for example, I have the same 3 groups over here, if there was a way for me to not break these blocks up and essentially just simply give one of these over here, put one of these over here and put one of these over here, and then the next one I can put over here and I can put over here, and I'm already done with these blocks of 10, right? So now it's you can imagine that the whole operation is going to take essentially much less time, right? Or essentially, for example, these blocks of 1000. So what I can do is that I don't simply have to break them up, because I want to divide by 3. I will bring one of them over here, the other one I will give it over here, and then just the other one give it over here, right? So then it's of course going to take, and as you can see, I'm already almost done with the whole operation, and all that remains essentially is a couple of single pebbles over here and a couple of these over here, and then I'm almost done with the whole operation, right? So starting from the small things is not going to be very clever. Starting with the largest groups that you have is always going to take much less time and much less, and of course, and then based on that, it's going to be, of course, the better strategy, of course, right? So now, instead of essentially using this model every time to do essentially a division, what I'm going to do, what we can do is that we can essentially have this essentially have the same strategy, meaning starting from the largest groups that you have, and then somehow essentially automate it, have it automated. Having it automated means that essentially automation in this area. What this means is that now we have used this, all of this model essentially, and all of these blocks and everything, to teach us essentially what sort of strategy to pick, basically. And what we learned was that we will just simply start with the biggest groups that we have, and then we will end up with the smallest groups that we have, right? So that way we can essentially save a lot of time, basically, right? And save a lot of computation. So then but then basically what we can do is that we can essentially now forget about completely, put the model aside, and essentially take the strategy out of the model, and then devise essentially an algorithm, which is essentially use the long division algorithm. And the good thing about this algorithm is that in this algorithm, then you don't have to work with the blocks anymore, or essentially you don't have to work with the model anymore. You can just simply work with the numbers, which is going to be much easier. So what we will do in the next video is that we will essentially take this strategy. Using this strategy, we will build our long division algorithm, and then using that algorithm, we can easily basically divide all kinds of numbers, 6-digit numbers, 7-digit numbers, 10-digit numbers. Then it doesn't matter how large your number is, it's going to be a very easy process, basically. So I will see you in the next video with the long division algorithm. Okay, so now let's talk about the long division algorithm. And what that is essentially the exact same model that we have here, meaning what we did in this model, starting from the largest group that we had and distributing them over our groups over here. But essentially in the long division algorithm, you will not work with this model of essentially pebbles and groups of pebbles and things like that. You will just simply work with numbers. Okay, so what you will do is that, suppose that we have essentially the exact same number over here, 3,253, and you want to divide it by a 3, right? Now in the long division algorithm, the way that you would write it you would write this as 3253 and then divide that by a 3. You would write it this way, and then we draw essentially a line on top of this number, so that we can write a couple of things up here, and that's essentially what we can start with, right? Now over here, basically what we said was that we will start essentially with the largest groups that we have in the number and distribute them. Okay, so we will do the exact same thing over here. So in this number, essentially this is the ones place value, the tens place value, the hundreds place value, and the thousands place value. So the largest essentially groups, or essentially the largest place value that we have in this number essentially is a 3, right? So and this means that essentially this is 3 groups of thousands basically, which means that this is essentially the value of this digit is essentially 3000, right? Now if I have these 3 groups of thousands over here, and if I want to essentially distribute them evenly among these 3 groups, so what I can do is that I can just simply give one of them to this group, give the other one to this group, and give the other one to this group, meaning essentially that each of the groups is going to get essentially one of these groups of 1000 basically, right? So the exact same thing we can do over here, but then in the long division algorithm, essentially what people usually say essentially internally, or what they think, is essentially, so 3 goes into 3 basically one time, and this number 1 essentially you're supposed to write it right on top of the 3 over here, right? So we say essentially 3 goes into 3 one time, or essentially what that means is essentially 3 divided by 3 is equal to 1, right? So 3 divided by 3 is equal to 1. Now this 3 is this 3 over here. This 3 is this 3 over here. And then the 1, I've written it on top of this. So what this means, and then the meaning of this 1 is that when I divide essentially these 3 groups among these 3 groups, each of the groups is going to get essentially one group of 1000 basically, which is exactly what we got over here. So then this group got essentially one group of 1000, this group essentially got one group of 1000, and this group essentially got another group of each group essentially gets basically one group of 1000 basically. Right? So now the largest basically group that we had in the number was evenly distributed among the 3 groups, and we didn't even have to break anything up. Exactly the way that the groups were, we are able to essentially distribute them evenly without any problems, right? Now we get essentially to 200, right? Now when we get to 200, essentially again we can ask the same question. 3 goes into 2 how many times? Or essentially what is basically what is essentially a 2, for example, which in this case essentially is a 200. What is a 2 divided by 3, right? And you can see that here essentially I cannot do this operation, because essentially I have 2 groups over here, or essentially 2 objects over here. You can think of them as 2 objects essentially, something like that. And then I want to distribute these 2 objects evenly among 3 groups. So the first group gets essentially one object, the second group gets another object, and the third group is not going to get anything. So the operation is not possible, right? So in order to solve this kind of this problem, what I'm going to do is that I'm going to have to, so I have essentially only two of these groups, right? So I'm going to have to essentially break these up, right? I'm going to need to break these up, because essentially each of these groups is nothing but essentially 10 of these 10 groups basically. So essentially 10 of these 10 groups, when I put them together, becomes one of these 100 groups, right? So then I will just simply break them up so that I can distribute them evenly among all of the three groups that I have, right? And when I break them up, these simply becomes essentially, they will not remain groups of 100, they will become groups of 10, right? So I had essentially 1, 2, 3, 4, and 5 groups of 10 here, another 10 over here, another 10 over here. So that's 10 plus a 5. Then that becomes essentially 25 groups of 10, right? So in order to break this up in the long division algorithm, I'll just simply now consider essentially these two digits together, which is the number 25, which means essentially 25 groups of 10 basically, right? So now I can ask the same question again, and now I can essentially answer it, meaning that I can say essentially 3 goes into 25 how many times, which means essentially what is 25 divided by 3. And but then basically one thing that I forgot over here to do was that when I was asking the question about, when I was considering only essentially the two groups of 100, and I asked the question 3 goes into 2 how many times, meaning essentially what is 2 divided by 3, then essentially what this means is that essentially what is essentially this 2 over here is in the hundreds place value. So I have essentially a 200 divided by 3, right? And I can, on top of this number, I can write either a 0 or a 1 or a 2 or a 3 all the way up to 9, right? Meaning that I cannot write, for example, an 11 over here or a 12 over here. So that's not possible, of course. I have to write I can write only a single digit on top of this number, right? So now if I write, so essentially 3 goes into 2 how many times, that means essentially what is 200 divided by 3, right? And if I write even a 1 over here, that means essentially 1 times, that means essentially each of the 3 groups that I have, and I have essentially these and I have a group of 100 here, and I have another group of 100 here. If I write even a 1 over here, that means that essentially each of these groups essentially gets one group of 100, meaning one group of 100 goes here, one group of 100 goes here, and then there is some imaginary group of 100 over here, from which I've given essentially 100 over here. But that's not the case, meaning that this third group does not exist, right? So I cannot even write a 1 over here. I have to essentially write a 0 over here, meaning that 3 goes into 2 how many times? 0 times, not even 1 time, right? And of course it's not possible to go the other way as well either, meaning I cannot write a 2, meaning that if I wrote a 2 over here, that would mean that essentially each of these groups essentially would have gotten basically 2 of these essentially groups of 100, right? So that's what I forgot to write over here, which means that when you ask this question and do the operation basically, then basically you have to, when the operation is not possible, meaning that when this digit is some digit smaller than this digit, then of course you would have to write the 0 on top of this digit over here, right? Now, so we saw that essentially with the two groups of 100 that we have over here, this operation was not possible. Now what we do is that we break up these two groups of 100, and each of them gives us essentially 10 groups of 10. So then I have essentially 10 groups of 10 here, another 10 groups of 10 here, 5 groups of 10 over here, so that's 25 groups of 10, which is essentially these two groups considered together. So now I have 25 groups of 10, and I want to know how I can basically divide them among the three groups, which means essentially 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. Let me draw these as well this way. So that's basically 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and 25. So these are basically groups of 10. And we have essentially the three groups where essentially among which we want to distribute these. So then what I can do is that essentially I give basically, essentially, for example, 8 of these to the first group. That's 8 of these to the first group. So this goes over here. And another 8 I'm going to give to the second group. This goes over here. And 6 and 2. So these over here I'm going to give, these 8 I'm going to give to the third group, which means that now this group essentially gets 8 group of 10, 8 group of 10, 8 group of 10, and 1 remains, right? One of them remains. So we will do the exact same thing over here. So we got the 8 over here. Now I ask the question again. 3 goes into 25 how many times? That's 8 times, because 8 times 3 is equal to 24, but then 9 times 3 is equal to 27, which is larger than this number. So I cannot go with 9, I have to go with 8, which means that essentially 8 times 3 is equal to 24, and now I can write essentially the 8 over here on top of 5 exactly. 8 times 5 is equal to 24, and then if you subtract, now I forgot to do the subtraction in the beginning. So when you ask essentially, when you consider this digit over here, and 3 goes into 3 one time, so 1 times 3 is equal to 3, and then you have to subtract, because you're essentially the 3 groups of 1,000, you're essentially taking them away. So you have to, of course, you have to subtract. So 3 times 3 is equal to 0. And then basically what you will do is that you will essentially bring down the next digit, which is essentially the 2. And then you will ask the question, 3 goes into 2 how many times? The answer was 0. And then basically, because we saw that basically then we had to essentially break those groups up in order to make 5 groups of 10, then I will bring another digit down. So now I have a group of 25, 25 groups of 10 basically. Then again I'll ask the question, 3 goes into 8. 3 goes into 25 how many times? The answer was 8, so I write the 8 over here. 8 times 3 is equal to 24. Again, I have to subtract, because we are taking things away basically, right? So then basically now we can essentially subtract basically, and 25 minus 24 is equal to essentially 1, which is essentially the one group that was left essentially in the operation that I just did over here. There was one group left, right? And that's essentially the one group of 10 basically, right? Now basically, now I have to now essentially I have to bring in the 3 loose pebbles that I still have essentially remaining in this number, right? So I bring this down, meaning that, and what that means is that essentially the one group of 10 that is remaining. So this is one group of 10, this is 3 groups of 1, right? So the one group of 10 that is remaining, that's essentially one group of 10 and 3 groups of 1 that's remaining, and I want to distribute this evenly among the 3 groups basically. So then these are basically the 3 groups. But of course this way the operation is not going to be possible, right? Because you have mixed things put together. This is a group of 10, this is a group of 1, so you cannot work with them properly. So what you need to do is that you can break this up. So I will break this up into 2, 4, 6, 8, and 10 loose pebbles basically. And when you bring this digit down here and write the number as 13, that means essentially that you have essentially broken this group up, and now you have 13 loose pebbles, right? And now the operation is easy. So 13, essentially 3, 4, I give essentially 4 of these, 4 into, basically, I give essentially 4 of these over here. 4 of them, I bring them over here, and then basically another 4 of them, I give them to, I give them to this group, and 1 pebble is remaining, right? So we can, the same operation now we can essentially do it in the long division algorithm. So then I ask the question, 3 goes into 13 how many times, which means essentially what is 13 divided by 3? And the answer is essentially, if I pick essentially 4 times 3 is equal to 12, and 1 remains basically. 4 times 3 is equal to 12, but then 5 times 3 is equal to basically 15. Now since 15 is larger than this number, of course I cannot consider this operation. I have to go with this one. So I put the 4 over here, and then 4 times 3 is equal to 12, and then subtract. 13 minus 12 is equal to 1, and that's essentially, that's the one single pebble that was remaining here, right? And the answer is essentially, our operation essentially is now exactly like this. Our operation is exactly like this. So we wanted to basically divide 3253 by 3, and now we essentially did the number 3253, so that's 3253, and we wanted to divide that by essentially by 3, which is the 3 over here, and we got essentially this number over here, which is 1084, and then with essentially with the remainder of 1, right? Now when you get the remainder of anything other than 0, that means that essentially the number that you started with, I mean the number that you want to divide by the other number, this number is not divisible by this number, meaning that it doesn't go evenly into that number. There is essentially some remainder, right? If you divide a number by some other number, and then if the remainder is 0, then that means that essentially that number is exactly divisible by the other number. For example, if you write, for example, 8 divided by 2, right? In this operation, I have essentially 8 pebbles here, and I have 2 groups here, and I want to distribute these. So I give essentially 4 of these pebbles to this group, and the other 4 essentially I give to this group, and there is no remainder. So then I can say that 8 is divisible by 2, because 8 divided by 2 is equal to 4, and the remainder is 0. But then in this case, we can say that essentially 3253, when you divide it essentially by 3, it's equal to 1084, and then there is a remainder 1, right? So then this number is not divisible by 3 basically, right? So that is basically, and then there is one more thing that I need to also tell you about this operation, and that is basically the names of essentially these numbers over here. There is essentially in each of the in every basically in every division operation, basically you have this number over here, you have this number over here, you have essentially this number over here, you have this number over here, and you have this number over here. Okay. Now the names, and in mathematics there is essentially names for these, and that essentially makes things easier. Meaning that when you want to talk about these specific numbers, you can just simply talk about them. Now this number over here is called the dividend. This number over here is called the dividend. This number over here is called the divisor. Okay, this number is called the divisor. This number over here is called the quotient. And this number over here is called the remainder. Okay, so we have basically the dividend, we have the dividend, we have the divisor, we have the quotient, and we have the remainder. Okay, so this and then again, this operation you can also write it in, well, many different forms, meaning that essentially the numbers that we had, 3253, and then you can write it divided by, and then divided by 3 is equal to 1083, and a remainder 1 basically, right? The same essentially the exact same operation, you can write it as 3253, and instead of this sign over here, you can use this sign, divided by 3 is equal to 1083 remainder 1 basically. You can write it this way, or you can even use a quotient, meaning you can write 3253 divided by 3 is equal to 1083 remainder 1. You can write it this way as well. And so then when you write your operation essentially this way, again we have the exact same names basically, the dividend, the divisor, the quotient, and then basically the remainder, which means that this is the dividend, this number over here is the dividend, this number over here, this number over here is the divisor, this number over here is the quotient, and this number over here is the remainder. Okay, and again the same thing, the dividend, the divisor, the quotient, the remainder, the dividend, the divisor, the quotient, and the remainder. Now there is one more thing that again you need to know about essentially division, and that is the fact that when you write essentially your numbers in the form of fraction, essentially your divisions, when you write them in the form of fraction, there is one essentially number on top of the fraction, there is another number on the bottom of the fraction. The number on the top of the fraction is called the numerator, and the number on the bottom of the fraction is called the denominator. Okay, so the number on the top of the fraction is the numerator, the number on the bottom of the fraction is called the denominator. And that's basically essentially the operation of essentially everything about division, all that you need to know. Now, another thing that I need to add here is that when you work essentially with the long division algorithm, there is always these tips and tricks that you need to know in order to essentially to work with the long division algorithm. And those are usually the things that people just simply memorize. Those are usually the things that people just simply memorize, and they memorize these things and they don't even understand what they're doing. They just simply do them, okay, without understanding what they're doing. And those are usually the things that students learn from their teachers, and then they just copy those things, and then of course they do the operation. But the problem with that is that they don't they don't understand really why they're doing essentially all of those different operations. Now, of course, all of those things you'll have to, as you work with the long division algorithm, you'll have to essentially learn them and use them. But as long as essentially you understand this video and the previous video, meaning that you understand essentially the foundations of division, and then you understand essentially the structure of the long division algorithm, then essentially those little things, we can learn them as we go along. So I will essentially keep using essentially the long division algorithm essentially often enough so that we can learn essentially everything there is about essentially this algorithm basically. Now in the next video we will talk about dividing and multiplying by different factors of 10, which is very useful and helpful when you work with numbers, basically when you do calculation on numbers. So I'll see you in the next video, and thank you. Okay, so welcome back. Now before we talk about essentially dividing and multiplying by different factors of 10, we need to know a little bit more about essentially multiplication. So about multiplication, so first we need to know about essentially the model that we use essentially for multiplication and the concept of multiplication, and then we will essentially talk a little bit more about basically the long multiplication algorithm, and then basically we will be able to use it essentially in calculation and arithmetic and that sort of thing. Of course, we have learned a little bit about multiplication in the previous course, but here we will make it essentially a little bit more advanced, basically based on our needs. So what is multiplication? Multiplication essentially is nothing but repeated addition. What I mean by that, what is repeated addition? So suppose that you have essentially all of these seats over here. So suppose that you have these different seats over here, and we have essentially 6 of them. So we have 6 seats over here. In the first seat, 2 people can sit. In the second seat, 2 people can sit. in the third seat, 2 people can sit, and again 2 people and 2 people and 2 people, right? Now if you want to calculate essentially the total number of seats, the total number of people that can sit in these seats, that would be essentially 2 plus another 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 2, and that's essentially 6 times. So that's 6 times, and that's nothing but the 12, right? Essentially 2 plus 2 plus 2 plus 2 plus 2 plus 2 is equal to 12, right? Now, of course, you can imagine that adding 2 to itself, essentially 6 times, you can essentially do the arithmetic easily. But suppose that, for example, you had, for example, 2 plus 2 plus 2 and so on and so forth plus 2, and that was, for example, 1000, for example, 24 times. Then if you were to do this, then of course the operation would be a little bit complicated, meaning that you would have to just sit and do the addition at least a couple of hours, and so it wouldn't be easy. So then how could we do this operation more easily? To do this operation, what we can say is that when we say essentially 2 plus 2 plus 2 plus 2 6 times, we can write the same operation. We can write it as 6 times 2 basically, or essentially we can write 6 2's basically. We can write essentially 6 2's, or essentially the 6 2's we can write it as 12, or we can write it as 6 essentially times 2, which again we can write it as 12. This is just 6 2's, or essentially 6 times 2 is another way of writing essentially this addition over here. And instead of writing the word times, basically we can write essentially 6 times 2 is equal to 12, right? So we can then basically we know that essentially now 6 times 2 is equal to 12. And in the exact same way, then basically we came up with all of the multiplication tables for the numbers essentially 2, 3, 4, 5, 6, 7, and 8 and 9, right? And of course all the other numbers, of course you can build the multiplication for all the other numbers, like for example like 1, or essentially like 10, or like 11, and so on and so forth. You can build, but those are essentially not necessary, meaning the multiplication for table for 10 you don't need, for 1 you don't need, because essentially 1 times any number is that number itself. Multiplication table of 10 is just a 0 added to the front of that number. The multiplication table for 11 just simply not needed, because the multiplication gets unnecessarily too complicated to do it in your head. So you can essentially, using the same strategy that we used over here, you can essentially build the multiplication table of essentially all of these numbers, which we did in the previous video, right? And so essentially now I know what is 6 times 1, 6 times 2, 6 times 3, 6 times 4, 2 times 3, 2 times 4, 2 times 5, 2 times 6, 3 times 1, 3 times 2, and essentially all the numbers basically. Okay? So now basically what I can do is that in the exact same way that, and then basically as for example as 6 times 2, I can write it this way as a 12, or I can write essentially 6 times basically a 2 is equal to 12. I can write it this way as well. And because of the fact that essentially now we have essentially all of these multiplication tables, instead of writing a 6 times 2, I can essentially put any number over here and calculate. Of course, I would have to do a little bit more of work and a little bit more of understanding and a couple of techniques, but the process is going to be the same. Meaning that instead of 6 times 2, I could write, for example, 3,526, for example, times, for example, 12. We could calculate this one. Okay. Now, how do you do this? So let's start from a simple case with a number like, for example, a simpler case, for example. Let's say that I want to calculate 254 times a 7, for example. I want to do basically this calculation. So how do I do it? So basically, first of all, you need to take the place values of these numbers into consideration, meaning that essentially the 4 over here is in the ones place value, the 5 is in the tens place value, and the 2 is in the hundreds place value, which means that essentially the 4 means 4 ones, the 5 means 5 tens, which is a 50, and the 2 means essentially 200s, which is a 200, right? And multiplying it by 7, that means essentially you're essentially multiplying all of these digits by essentially by a factor of 7, or essentially by 7, which means when I multiply each of those digits essentially by a 7, what that means is that I'm saying essentially, for example, 7 times a 4, that's a 28, meaning 7 times 4 ones basically. 7 times a 5 would be 7 times basically 5 tens, meaning 7 times 50. And 7 times a 2 would be 7 times 2 hundredths, which is essentially, well, 7 times 200 essentially, right? So the place value has to be taken into consideration. So I have now basically this place value over here. I have the second place value, and I have the third place value over here. So I have the ones place value, the tens, and the hundreds place value, right? So just like I write basically, for example, 7 times 4 is equal to 28, I can basically do this calculation, but then essentially the 7 times 4 is a 28. So I can write the 28 over here. Then basically I could do this part, meaning 7 times 5, basically I can do that again separately and write the number over here. And basically the 7 times 2, I can essentially do it separately and then write them down. And then basically I could add everything up together, right? And I will do that essentially over here first, and then we will get to the long multiplication algorithm. Let's say that we have the exact same number, 254 times a 7, and to do this operation, what I will do is that to make it simple, I will expand this number so that we know essentially what this number is. So that's essentially a 254. Now this 2 over here is a 2 times 100, because essentially the 2 is in the hundreds place value. Then this 5 is a 5 times 10, which essentially because the 5 is in the tens place value. And then this 4 over here is nothing but essentially 4 times 1, because the 4 is in the ones place value, right? And you're multiplying essentially this whole thing by a 7, right? Which means that essentially each and every one of these numbers, each is being essentially multiplied by a factor of 7. which means that now I can write that essentially that this 7 is being multiplied by this whole number. So I will multiply this whole thing by a factor of 7, right? So then this operation, since this whole thing is being multiplied by 7, that means that essentially each and every item in this whole thing is being multiplied by 7. So this item is being multiplied by 7, this one and this one all are being multiplied by 7. So then the operation becomes essentially 7 times this item plus 7 times this item plus essentially 7 times this item, right? So then I will write essentially 7 times basically 2 times 100. So that's one part. And then whatever this is, I need to add it to 7 times basically 5 times 10. And then I need to add this to, again over here, 7 times 4 times 1 basically. Now, what is 7 times 2 times 100? That's a 14 times 100, which is equal to a 1400. What is 7 times 5 times 10? That's a 35 times 10, which is a 350. And what is 7 times 4 times 1? That's a 28, right? Now you can basically add these numbers together, meaning that you have a 1400, a 350, and a 28. So you can essentially add all of these together. You get an 8. You get essentially a 5 plus 2 is equal to 7. And you get essentially a 4 plus 3 is equal to 7 and a 1. So the number is going to be 1778 basically. And if you do this on a calculator, you have basically 254. You have essentially a 254 times 7. 254 times a 7, which is equal to 1778, which is essentially what I got here. So then based on this example, you can see that the number like, for example, 254 is nothing but essentially a 200 and essentially a 50 and a 4 basically. So which means that essentially if you had a 4, if you had a 50, if you had a 200, if you essentially put the whole thing together, you would get essentially a 254, right? So that's basically this operation over here. Now, you saw that essentially the multiplication of 7 by this whole number was actually nothing but essentially the multiplying 7 by the 200 part plus essentially multiplying 7 by the 50 part plus essentially the multiplication of 7 by the 4 part. And we can do the same thing over here, which means that essentially when I'm multiplying basically the 7 by 254, first what I need to do is multiply the 7 by the 4 part. Then I need to multiply the 7 by the 50 part. And then I need to multiply the 7 by the 200 part. And then whatever I get, that becomes essentially my number, right? So now essentially things essentially become very simple. So now how do I do this calculation? So first I multiply the 7 by the 4 part. So 7 times 4 is equal to 28, right? So 7 times 4 is equal to 28. But now the problem is that because essentially the number that we get over here, it has the 1's place value, the 10's place value, and the 100's place value. It's essentially the 28, I cannot write it over here because this is the 1's place value in the number, And in the ones place value, you can write only one digit. 0, 1, 2, 3, 4, all the way up to 9 basically. So the whole 28, I cannot write it over here. So then what I can do is that I'm going to, essentially a 28 is a number that has a ones place value and a tens place value. So the 2 over here is in the tens place value. So I write the 8 over here, but then the 20 I will keep it over here, right? At the 20 I will keep it over here, and I have to make sure that I will add this back to the whole result that I'm going to get for this number. Now what is 7 times 50? 7 times 5? 7 times 5 is equal to 35, right? So again, I cannot write the 35 over here. And moreover, basically now this operation that I'm doing here is actually not 7 times 5, because this 5 actually is in the tens place value. So it does represent the 50. So that's actually 7 times a 50. 7 times a 50 is equal to 350, right? 7 times a 50 is equal to a 350. Now a 350 plus a 20 is equal to 370, right? So 370, if I were to essentially put this number in the tens place value, so I have basically the ones place value, I have the tens place value, and I have the essentially the hundreds place value. So I put the 70, essentially the 7 over here, which actually means a 70, right? I put it in the tens place value, which means that the value still remains a 70, right? And I have essentially a 300 left, so I have to essentially keep this 300, and I can cross the 20 because I already essentially brought it in as a part of the calculation, so I don't have to take that into consideration, right? So now I can essentially erase all of these things, and I can erase this, and I can erase this. So the 300 I have to bring in, right? Now the rest of the calculation, what remains is 7 times a 2, which is essentially nothing but 7 times a 200, because the 2 is in the hundreds place value and represents a 2 times 100, which is 200. Now 7 times 200 is the same thing as 1400, right? That's a 1400. Now we have a 1400 and a 300. If I add them together, I'll get a 1700. So then basically the 7 over here, I can put it over here, which, because it is in the hundreds place value, represents a 700. And so what remains from this number is 1000. Is essentially the 700 I've put over here. So 1700 is equal to a 1000 plus a 700, right? So I put the 700 already over here. What remains is 1000 that I have to essentially bring back into the result over here. And basically, so what I need to do is that I will create another place value here, which is essentially the thousands place value. And if I put a 1 over here, that means that essentially 1 times 1000 is equal to 1000. So now my 1000 is also taken care of. And so the number now becomes essentially 1778. And if you do the calculation on calculator, you have essentially 254 times the 7 is equal to 1778, which is exactly right, right? Now you saw that essentially in this calculation that I did over here, things got a little bit complicated, meaning that I had to keep track of essentially all of these numbers. I had to keep track of all of these different place values, and so on and so forth, right? So how do I make this a little bit simpler so that I can work with it more efficiently? So the same calculation 254, the same calculation, which is essentially 254 times a 7, I want to essentially do this calculation. So how do I do that? So we will, of course, the basic strategy that we had, we will have to keep it. Meaning that I'm going to say that basically that essentially this number 254 is a 200 plus a 50 plus a 4, and I can essentially calculate 7 times a 4, and then 7 times a 50, and then 7 times a 200. Essentially keep all of those separate calculations, then put them together. That becomes essentially my complete number. This part of the strategy, of course, I have to keep. Now if I say, for example, that if I multiplied essentially the 7 by the 4 over here, 7 times 4 is equal to 28. I'm not keeping track of any place values or anything like that. That was just for the sake of understanding this algorithm over here. Now what I'm doing is that I'm just simply saying what is 7 times 4, and that's essentially 7 times a 4 is equal to 28. Now I'm going to write essentially the 8 over here, and I'm going to keep the 2 over here. Now, so this part of the calculation is done, right? So then I have to move on to the next part of the calculation, which is this part over here. Now I'm going to say what is 7 times 5. 7 times 5 is equal to 35, right? So I take this number 35, and this 2 was remaining from the previous section. And this 2 I added to 35, so then I will get the 37, and the 37 I will have to put it here. So I put the 7 over here and keep the 3. So now I have essentially the 3 over here, right? Now again, this part of the calculation is done, and then we will move to this part of the calculation. So now what is 7 times 2? 7 times 2 is equal to 14. And then we had also a 3 over here, so 14 plus 3 is equal to 17. And 17, essentially I put the 7 over here, and what remains essentially is a 1, right? And then I will put the 1 over here, and then the result of the calculation becomes 1778, which is exactly what we got in the previous step, right? So this essentially means that of course the algorithm itself, you need to understand how it works, right? You need to understand how it works, but then essentially if you follow essentially the exact strategy that then I used over here, then you don't have to keep track of all of those place values and everything. Just by following the exact same thing, you will get the same result. Of course, the understanding behind all of this is important, because later on, essentially, this understanding is going to be necessary to understand many other things in mathematics. For example, when you get to calculus, or when you get to many other parts, essentially, that understanding about this previous part is absolutely necessary. Okay, so I will end this video here. In the next video I will do another essentially example of multiplication, and then we will go essentially through the understanding, and then again we will go through the technique over here, and then we will move to essentially the next parts on or less. Thank you.